Hi, Science 20s. Mr. Riley here. We're going to do another really quick little video on calculating acceleration. So acceleration, when we're talking about acceleration, we're talking about non-uniform motion. So far, everything we've talked about is uniform motion, which would be an object traveling at a constant velocity. It's not slowing up or it's not slowing down. So when we're talking about acceleration, we're talking about an object that is speeding up, or if it has negative acceleration, that means that it's slowing down. So let's just jump right into looking at the formula. So when we look in our data booklet, we're going to find this formula. Acceleration, which we see here is a vector quantity, so it needs direction, is calculated by taking the change in velocity. So we see that Greek letter delta there, divided by the change in time. Another way we could describe it, it is the rate of change in velocity. Okay. Now we might also see it looking like this, and in this case, I see this VF for final and VI for initial. And so if I need to find the change in velocity, I would just take the final velocity and I would subtract the initial velocity, and that would give me the change in velocity. So let's look at this example here, and I'll let you guys do some practice on your own. So we have a car accelerating from 8 meters per second to 20 meters per second in 4.0 seconds. And I want to know what is the acceleration of this object. Okay, so first thing, I'm going to write down all the things that I have. Of course, I don't have the acceleration. That is what I am looking for. Another variable I have right here, my unit is seconds, so I know that's going to be the time, and that's 4.0 seconds, and that's really my delta t. So we're looking at the change in velocity between 0 seconds and 4 seconds. And now I have two velocities here. So I'm going to need to calculate the change in velocity. So my velocity is going from 8 meters per second at 0 seconds to 20 meters per second at 4 seconds. So I have this, I would call my VF, my V final, and this is my V initial. So if I write those down, okay, I got my VF, it's 20 meters per second. I got my VI, it's 8.0 meters per second. I can use this portion of the formula for that part if I like. So I'm going to put in my formula here. Acceleration equals VF minus VI over. Now I'm actually going to combine these two formulas right here. I already know what delta t is, so I'm going to put that delta t in here. Now I'm just going to plug these in. So I'm going to have 20 meters per second minus my 8.0 meters per second, and I divide that all by my 4.0 seconds, and that's going to be equal to my acceleration. So when I take a little bit, I guess, closer look at this, 20 minus 8 is going to be 12. I'll put a 0.0 for now, meters per second. And I'm going to divide that by my 4.0 seconds. Now, what I'm going to get here is actually, for my units, I'm going to get a meter per second per second. And the way that we say that, the unit for acceleration that we're going to get here is what's called meter per second squared. So we take 12 divided by 4, and I want 2 sig digs here. So I'm going to get 12 divided by 4 is 3. I'm going to get 3.0. My acceleration is equal to 3.0 meters per second squared. And that's the unit that we're always going to use for acceleration. So we're not going to be dealing with, we're going to do like kilometers per hour squared. So anytime you see kilometers or hours, you want to convert those to meters and seconds when we're doing this stuff. And that's how we calculate acceleration. Okay, good luck. I want you guys to do whatever the next page is. Page 17 for some practice. Later.